So welcome to our last asynchronous class. And in this session, we're going to learn how to use an ANOVA to test hypotheses about three or more means. Now, there's two kinds of ANOVAs. One is called a between subjects design, and one is called a within subjects design. The first one, between subjects design, is the most frequently used one. So the first part of our session today we'll focus on the between subjects ANOVA design. And then there'll be a second video which focuses on the within subjects design. We'll also learn how to conduct post hoc analyses as appropriate, and of course, how to summarize the findings of ANOVA using APA formatting. So ANOVA stands for Analysis of Variance, and it's used to compare the means of more than two groups. You know that if you have just two groups, then you would use a t-test. And we've already covered that. That was the very first statistical test we learned how to do together. But the question might have come up, well, what if we have more than two groups that we'd like to compare the means of? Well, the way we do that is with an ANOVA. Now, there's two kinds of study designs, like I mentioned before. The between subjects design, which is quite widely used, and the within subjects design, which is less widely used. And when we go over the difference between them, I think you'll see why the first one is more widely used than the second. So in the first one, the between subjects ANOVA, it's really important to note that different participants are observed in each group. Each subject is a member of only one of the groups. And one way means that we're testing only one factor. And we'll see that in our first example. You can have more than one factor that you're looking at. That would be called, for example, a two-way ANOVA. Now, the ANOVA is based on two different kinds of variations. So if we looked at these groups, Group A, Group C, B, Group C, Group D, and I asked you, given this graph, and what this is response rates for various groups to some stimulus, do you think these groups are very different? Now, the red dot represents the mean of each group. And if I were to ask you, does it seem like there's a big difference between the groups? I think most of you would say, no, I mean, there's a little bit of difference, but it doesn't seem like there is any significant difference between the groups. So let's take a look at why this graph lends us to that conclusion. Well, notice that there's large variation within each group. Within each group, there's a lot of variation. See that? And about the same amount of variation within each group. So within each group, there's a large amount of variation. But between the groups, like if at the beginning I asked you, how different do you think the groups are? You probably said, not that different at all. Between the groups, there's very little variation. So here's a picture of large variation within the groups, but very small variation between the groups. Okay, let's contrast that with this picture. Here, again, we have four groups, Group A, Group B, Group C, Group D, and again, we're looking at response to a stimulus. Now, if I asked you, does it look like the groups are different? Are there significant differences between the groups? I think most of you would say yes. The groups seem to be very different. Let's think about why this graph is so different in appearance than the first graph. In this graph, notice that there's small variation within the group. Within each group, there's not a lot of variation. However, between the groups, there's large variation. So this picture would lead us to think, oh, the groups are different. Why is that? Because the variation between the groups is large, whereas the variation within the groups is small. This first picture would lead us to think, nah, these groups are pretty much the same. And why is that? Because the variation between the groups is small, but the variation within the groups is large. Okay, so how do we put these pictures into a test statistic? Well, the test statistic we use is called F, and it's simply the ratio of the variation between the groups and the variation within the groups. So if you have large values of F, What that means is there's large variation between the groups compared to the variation within the groups. In other words, you're looking at this picture here. This would give you a large value for F. However, when the variation between is small and the variation within is large, as in our first group, this kind of number is a small number. Think about a fraction when you have a small number on top and a large number on the bottom. The overall fraction value is small. So this picture would lead us to small values of F. Okay? All right. So let's take a look then at where we are. So the distribution, the test statistic is called the F statistic because it uses the F distribution. Just like we were introduced to the chi-square distribution last class, the F distribution also is similar to the chi-square distribution in that it's right skewed. The shape changes depending on the number of categories, and all of the F statistics are positive. So when you look at an F statistic, you're not thinking of a symmetric curve where the test statistic tells you how many jumps you are away from a mean that's in the middle. It's nothing like that, okay? So the F distribution is very different than the T distribution or the normal distribution, but it's similar in its characteristics to the chi-square distribution. Now, there are lots of terms that are associated with an ANOVA. I'm going to go over them just so that when you see them, you're familiar with them. You don't have to memorize these terms. I don't think I've seen them in particular in any samples of multiple choice exams that you'll be required to take. But I am going to go over these because when you read research that involves ANOVAs, you're going to see these terms used, okay? All right. So there's something called explained variation and unexplained variation. So explained variation is simply the variation between the groups. The farther apart the means are, the greater the variation between the groups. So for example, in this picture here, remember the red dots are the means. They're very different. They're very far apart. So this picture would have a large explained variation. Unexplained variation is the variation within the group, all right? And so this picture here, again, would have a small amount of variation within the group, so small amount of unexplained variation, okay? And there are many synonyms for these, and you can see them here. It's also called the treatment variation. This one's sometimes called the error variation. So even more terms. The variation between the groups is sometimes also given one of these three. We already talked about the explained variation, but sometimes it's called the variation due to treatment or the variation due to factors. And the variation within the groups is sometimes called the variation due to error, the unexplained variation, we talked about that one before, and the residual variation. And again, this is just a term that's used. It doesn't refer to a mistake that was made. It's just the term that's used for this amount of variation. Okay. So just as a reminder, this section of the course of our lecture today is about one way between subjects ANOVA. And in this design, we're going to be comparing more than two groups, but it's really important to note that each subject belongs only to one group and is only measured one time. So I think before we do our next example or our first example of a between subjects ANOVA, we're going to stop the video here so that the video length isn't too long, and we'll have a second video with our example.